Welcome to Revolution Against Evolution. I'm your host, Doug Sharp, and today I have with me Derek Marshall.
Hello.
Who has been a regular on our show, and he has been, the Lord's been giving him a lot of information about his creation in a lot of different ways, and I want to give him an opportunity to express a few of his ideas concerning his creation function. But today we will be we're going to be talking about Danny Faulkner's article that he did about dark matter. And I think there's a lot of things that this pertains to. This is an enigma for evolutionists, but I think that with the revelations that we've gotten from Dr. Faulkner, and also Derek has got some ideas about this as well. We have an advantage here over the evolutionary explanation. Derek, tell us a little bit how you were able to interpret what Danny Faulkner was saying in this, and first of all explain a little bit about what dark matter is and how it relates to the creation.
Yeah, you mentioned it's a little bit of an enigma. That enigma is it's an opportunity for creationists to really come into their own in the way of dark matter is something that nobody knows what it is.
Right. And
that is an opportunity for us to allow the Lord to really speak to us and show us what it is. Before the secular scientists come up with it, and I think, and I truly believe that that's possible. And so, what over the last couple of weeks, I have several thrusts of my research, my creation function research. But over the last couple of weeks, I've been getting a lot of keys to look into this dark matter. I've been looking at it for several years, but I haven't been able to come up with anything. I've had a couple. Just a general idea of it in my mind, a very, very simplistic analogy in my mind, but I haven't been able to do anything with it really until the last couple of weeks. And all of a sudden, I get this big deluge of inspiration from the Word of God and from what I know from physics, from my physics background. So that prompted me to look at Dr. Faulkner, Danny Faulkner's paper. He's written a really nice paper on dark matter, the case for dark matter. It's like a 10 or 11 page manuscript. Mm-hmm. It basically tells you where it's at, what the current, or as of 2017 anyway, what the current research suggests what dark matter could be. And I just wanted to review that paper with us here now, and we can talk about what he's come up with, or what he was able to find. And he's a real life astronomer.
Yeah.
And he did that for many years. So he's got some personal research that he was able to add and really good insights. And if we have time, then maybe I can give you a few of my insights into what I see dark matter to be. And we can go with that.
Now let's back up for a minute. We're talking about the origin of the universe, the problem of the origin of the universe, and the characteristics of the universe. You know, why we have galaxies, and why we have stars, and why they behave in certain spiral type of manners. And of course, your creation function is all about the spiral.
That's right.
And because of that, we want to have you review, well, why is it a problem for evolution? What is it that they're having trouble figuring out? And I think that you have some insights in that.
Yeah, really, if there is a creationist dilemma, it's just basically some creationists are open to dark matter. Danny Faulkner makes a good case for why we should look at it. But really, creationists, and they should be skeptical of, just like any scientist, should be skeptical of new information, and especially when it's dealing with the unknown or something that is a mystery to us. We noticed that in galaxy clusters, there seems to be a very rapid breakup of galaxy clusters, and that lends itself very well to a young Earth creationism model. And also, from a design standpoint, everything being bound together by a very, very structural and not simplistic, but very easy to grasp idea like gravity, classical gravity, Newtonian gravity, seems to lend itself to a design perspective because it's just so orderly and it's so easy and accessible for anyone to figure out. It doesn't require any abstract math or anything. And plus, dark matter has found itself in Big Bang discussions quite a bit more now. They're trying to, and they have tried to tie it in to a Big Bang model, and of course Big Bang is not a friend to any creationist. So those are some potential things that the creationists have to kind of work their way through. But and that's where. But for my perspective, you mentioned the creation function, which is a mathematical function that's derived from Scripture that makes 7 rotations of a spiral. So we interpret that, and since we know that the Lord created the universe in 7 days, or the earth in 7 days, we interpret that as 7 rotations of creation. And that 7 rotations of creation is actually a logarithmic, equal angular logarithmic spiral, which is a numerical construct, and you get a set of numbers which I've been able to correspond to the Fibonacci series and the periodic table of the elements. And we find that from from plants to planets, from atoms to astronomy, we see these Fibonacci numbers.
Right.
And so what we have is a mathematical, or a spiral construct that gives us a mathematical pattern that generates number series that we see in growth all around us from all levels of creation, from the atom, as far as DNA, even quantum has Fibonacci numbers, all the way up to the orbits of planets. The difference, the amount of time it takes a planet to rotate or to orbit the sun, you take that amount of time and you compare that to the next planet over and its amount of time. That's a Fibonacci ratio, and that's a golden ratio. So we have a case for, we observe these spiral galaxies. Not all galaxies are spirals, but many are. That has the spiral pattern, and a spiral pattern fits the 7-day creation story or account very well. So for me, I tend to look at that.
Now, it seems to me the reason why they speculate there is dark matter is because according to the theory of galaxy formation, there's not enough matter in the galaxy to provide the gravitational attraction to hold it together as a structure. Is that really what's going on there?
Right. Yeah. So if we
they have some ideas. They have MONDs and MACHOs and WIMPs. So they were going to talk about MOND and MACHO and WIMPs today.
Yeah. So the only way that we can really tell what's out there is to see the light. Mm-hmm. And we have instrumentation now that can see all forms of light, visible light, X-rays, and you name it. We can view all forms of, or many forms of electromagnetic radiation to try to determine what is out there. And as Doug suggested, is that from a light to mass standpoint, ratio standpoint, there just doesn't seem to be enough mass to hold these large structures together. And we do other analyses like velocities, rotational velocities around the galaxies, and we expect the rotation of things that rotate around the galactic center to be the fastest, and then slower and slower as it goes out. And as a matter of fact, what it is the objects at the edge of the galaxies are moving faster, which implies there's more mass at the edges of the galaxies, which is counterintuitive to the idea that the mass should be centered towards the galactic center.
No, that is
So-
strange.
So you brought up MOND. MOND is a modified Newtonian dynamic, which is we go away from regular Newtonian dynamics, which is the nice, pretty, and clean way that we calculate gravity using the inverse square law, to something else. And we're thinking that maybe we don't understand the law of gravity as well as we thought. That's what MOND is.
Okay.
And then we have other MOND is an idea of that's changing the theory that we presently understand. We have a really neat cluster galaxy called the Bullet Cluster that is actually two clusters of galaxies that are converging. And each of these clusters have two unique features. They have the stars, and then they have the gas clouds. Well, the stars are far enough apart where they're not going to interact that much. But the gas clouds, when they collide, they do interact, and they slow down, and they no longer follow the motion of the stars. Well, the stars emit visible light, and the gas clouds emit X-rays. So we can watch where the center of mass of each of these aspects tends to go. And with MOND, if there's dark matter and it's some other form of explanation, the MOND should follow the X-ray. But what actually happens is the center of mass follows the visible light, which means neither MOND or classical gravity has the proper explanation for that. Neither fit the model of what we observed. So that strengthens the case for dark matter. Then we have, as you pointed out, the MACHOs. And the MACHOs are a different breed of animal. MACHOs include things like black holes, planets, and dwarf stars. And those...
And that stands for, MACHO stands for what?
Oh, I'm going to have to caught me on that one there. The MACHO. Massive complex halo objects.
Okay.
And they call them halo objects is because the way they determine if the way that where these MONDs would be, as I said, at the edge of galaxies. You have it seems to be the most amount of mass, and that's called the halo of a galaxy.
Okay.
So we wait for a MOND or a planet, a MACHO, I'm sorry, to go between a MOND and a star. And if the MOND is what we think it is,
the
MACHO, if the MACHO is what we think it is, then the light should have a little bit of what's called a micro-lensing effect through the MACHO. And we see that a little bit, but not nearly enough to account for all of that mass that would account for the velocities of around the very edge of the halo portion of a galaxy. So MACHOs don't really account for it. And then we have the WIMPs. And WIMPs, we're not really sure. These are weakly interacting massive particles. For a while, I thought WIMPs, and I still think WIMPs are a good candidate because we really don't know what they are. All we know is they should interact weakly with matter. It has to do with the weak force of matter, and so far, though, all of our attempts to find WIMPs we haven't found any. We haven't detected any WIMPs yet.
Yeah, that's a little bit like
So that's not
van der Waals forces between atoms. We really don't understand that either. This is sort of a weak bond attraction between different
I think
atoms.
that's related to how the charge. A molecule has charge. It'll have charge. But that charge, like anything else, is kind of an equilibrium balance of itself. That charge is very quickly moving around the molecule. And they think that whatever that frequency is that charge is moving around molecule A versus molecule B, that there might be a beat frequency, or there might be something like this happening that's causing a force or an attraction between the two. I'm not sure if that fits in with the WIMPs, but with the WIMPs, them being weakly interacting, that brings me to mind to think about beta decay and the weak force, and that fits more along the line of kind of where my personal interest is it's not regular what's called baryonic matter. All the matter that we're used to is called baryonic matter, protons, neutrons. This is not going to be baryonic matter, and plus the existence of WIPs requires kind of a little bit of an extension of the standard model of physics, which nobody really likes to do, but those are really kind of the three main focuses right now for what is dark matter, what could be dark matter.
It's sort of interesting to me that this type of physics sort of interacts between the largest structures known to man versus the smallest structures. You go from you actually have similar unknowns on both ends of the spectrum, where you have these massive objects out in outer space that are actually behaving in similar ways to what you see way down at the proton, neutron, electron level. And so I find that interesting and strange at the same time. But it's also sort of saying, well, there's a creator who used the same design way out there as when he designed the matter itself. And so this dark matter stuff is still a mystery, and maybe up to the point where you define it there, Derek.
Right. Well, I wanted to bring in, give a little bit of an education on gravity, classical Newtonian gravity. When I say give the inverse square law, so the closer something is the closer two things are that are attractive gravitationally, they'll feel a certain force. But as you pull them apart, that force diminishes at an inverse square rate. So it goes from if you have a force of 10, that diminishes to 5, and then half again, and half again, and they diminish very quickly. In the new Einstein general theory of relativity, you have what's called curved space. Now, curved space means it's something you have kind of like a flat sheet, which represents space-time, which represents the world that we live in. And more massive particles, if you dropped a bowling ball on this sheet, it's going to create like a divot. And that divot is kind of like a bowl shape. So if a particle comes in and it gets caught in this bowl, it's going to tend to orbit and be go like that, be attracted to it. So that's a pretty good and well-proven model of gravity, is this curved space. And so what we think is, or what I think is that dark matter is going to have to curve space somehow.
It also affects time, doesn't it?
Mm-hmm. Yes.
And that's also mind-boggling as well, because we really, some of the things when we measure out to galaxy level, you're talking hundreds, maybe thousands or millions of light years away. In that definition, you're looking at something that where that light source emitted that many years in the past, and we're looking at it as that particular at that particular time. So that may be a distortion that doesn't help us at all.
Right. So you've hit upon another aspect of what dark matter or space-time could do, is what is this apparent speed limit of light? And it's a very, very precise speed of light. That seems to be the maximum amount of velocity that anything could possibly go. The only things that attain that speed would be a pure photon, and in a vacuum are the only things. So dark matter is going to also, from my perspective, have to answer for, how does dark matter, or does dark matter have an effect on light propagation? I think that it does. Mm-hmm. You know, and I can kind of see a mechanism of how that works, based upon what I believe. I believe that we actually know what dark matter is. It's just the paradigm hasn't shifted. When we talk about space-time, let's talk about space. People think about what's out there. Mm-hmm. They think about space travel, being out in space. Space being a very, very open, free, area to move. But in actuality, when we talk about space, I believe that we need to be looking inward. And you could call it inner space. There's space that exists inside of every atom. You go deeper and deeper into the atom, past even the nucleus, and inside the very smallest elementary particles, there's still inner space in there. And I believe that that dark matter may exist in there, and that inner space has a lot to say about how light travels, how gravity works, even things more recent ideas like entanglement, which is, as Einstein called it, spooky action at a distance, meaning I could have a radio here and you could have a radio on Mars, and I could talk to you and the communication be instantaneous based upon probabilities and entanglement of photons and other particles, of elementary particles and atoms. That's very, very spooky stuff, but it's been shown to be true. Entanglement exists. They can routinely now entangle photons and play games with the probabilities and see if you move this photon over here, this photon also, I'm oversimplifying something that's very, very, even over my head actually, but that's a reality. So I think dark matter has a lot to do with electromagnetic wave propagation. I believe it has a lot to do with gravity. I believe when we understand dark matter, we will understand gravity. I believe it also has a lot to do with entanglement, and that has to do, like you mentioned, time. We don't really understand, I don't believe we understand time the way that we really need to. And that understanding can really only come from a creationist perspective, because we need to view time the way God views time. We only see a very, very tiny sliver of time that we're given.
Right.
But Christ and God, they occupy time, and I call it permanent time. They occupy time like it's territory. They know the end from the beginning, the beginning from the end. That's really, the way we experience time is weird. It's not really, it's because we're fallen, and we're sinners. That's why we experience time the way we do.
I've observed that we measure time by the rate of decay of stuff.
Right.
And maybe that is a little bit different than the way that is in heaven. In heaven you don't have any decay or death.
You have the opposite.
But that's an interesting question. Now, would you say that dark matter would be something like a space medium in which everything exists? Sort of like the dirt in which a plant grows, or something like that.
Yeah, I kind of named that the dark matter continuum. If you could imagine the universe being a large field, and each of us being a plant in the field, all of us sharing the same plot of dirt, so to speak. That would mean that there's in a typical like a field of corn or a forest, you're going to have commonalities attributes of that soil. You know, acidities may be the same, moisture levels are going to be similar, the amount of drainage, the amount of sand that's in the soil may be similar, and you're going to have water. There's going to be trees transpire water, and the water goes up into the firmament, and then it rains back down into the soil, and it leaches back towards the roots. So there's this water cycle that's common among the trees and the plants in a field, and I believe we have the same sort of cycle in our universe, so to speak. And I believe it's really counterintuitive. But I do believe that, like something like light, which is an electromagnetic wave or radio wave, we think that it's transmitted between us. But really, I believe the correct view is that signal is actually transmitted via the dark matter in inner space, because the only way we can really observe light is to look at an object. You know,
right, yeah.
It has to reflect or emit from an object, or reflect off another object. That's the only way we really experience waves or experience light. So it would make sense that to me that would be the inner space medium, or the dark matter continuum would be really where everything is happening.
So in my mind, this is a real mystery. It's something that it reveals our real lack of depth of understanding of what the nature of the universe is all about. And there's so much more to discover and to try to figure out. But we as tiny individuals here on this planet are trying to conduct these scientific investigations, so not being able to control an experiment to gain this physical understanding of something. So all you're left to do is observe what was coming in from outer space and try to make sense of it.
Right.
And like I think we've got MONDs and WIMPs and MACHOs. Trying to figure out. None of it quite works yet, and so this is an opportunity for us to, just if we want understanding of what the nature of the universe is, we need to get in tune with God and see if He reveals some revelation to us.
If something I like to say is, if you don't know the Creator, or if you have to know the Creator to know the creation.
That's right. We'll see you next time on Revolution Against Evolution. We hope you enjoyed our show.